Okay, we're going to take some notes on imaginary numbers. So today we kind of came across some of those, so here's another way to deal with them. So let's just say we had an example like x squared equals 9, and I wanted to know what numbers x could possibly be. So if we take the square root of both sides, because the opposite of a square is a square root, we get that x can either be a positive or a negative 3. Now the reason it can be positive or a negative 3 is that 3 squared equals 9 and negative 3 squared equals 9. But let's say that our problem was x squared equals negative 9. If we take the square root of both sides, we have that x equals the square root of negative 9. Well, if you have two numbers that are supposed to multiply to negative 9, they can't be the same number because a negative times a negative is a positive and a positive times a positive is a negative. But what we can do is we can write this as an imaginary number. So negative 9 can be separated into the square root of negative 1 times the square root of 9. We know the square root of 9, that is 3, and the square root of negative 1 is what we call I for imaginary. So I is the square root of negative 1. Now if we squared I, or squared the square root of negative 1, we would get negative 1. So two imaginary numbers can also be multiplied together. They equal negative 1. So what we're dealing with for finding the quadratic formula when we have imaginary is complex numbers. So we have all complex numbers or all real numbers and all of the imaginary numbers. So we're going to do some simplifying and then a little bit of solving right now. So let's simplify first the square root of 8. So 8 has a negative 1 and an 8. It also has a 4 and a 2. So you can take the square root of 4, which is a 2. The square root of negative 1 is an I, and the square root of 2 is still irrational, so that can simplify to 2I root 2. So using I as our square root of negative 1, we can take out the negative, and therefore our square root is no longer negative. Number 2, the square root of negative 2. So that is negative 1 times 2. 2 doesn't have any other factors. So the square root of negative 1 is I, and the square root of 2 stays the square root of 2. For the square root of negative 36, again, that can be negative 1 times 36, so the square root of negative 1 times the square root of 36. Square root of negative 1 we call I, and the square root of 36 is just 6, so that's 6I. Square root of 25, not negative, just a normal one. So don't forget, we still have our regular positive square roots. The square root of 25 is just 5. Which means, and you can have a negative in front. It's still a normal answer. It is a negative, and the square root of 25 is 5. So make sure you're very careful on, does it have a negative 1? Where is that negative? If it's inside of the square root, that's when we have I. So how you would use those. So here's some basic equations. I'm not going to do ones where you have to do a lot of factoring. We can solve these ones in a slightly different way, because the only variable in this one is an x squared. So the first thing I'm going to do is get my x squared by itself. So I'm going to subtract 100 from both sides. And I have 4x squared equals negative 100. I'm going to divide both sides by 4. And I have x squared equals negative 25. I have two equal signs. If I then square root both sides, I have the square root of negative 25. Well, I know the square root of 25 is 5. And the square root of negative 1 is I, so 5I. It is also plus or minus, because you can have the positive or negative answer for that one. So when we're solving for x, you can have the positive or negative answer. For the next problem, x squared equals 20, or x squared plus 20 equals 0. If we first subtract 20 from both sides, we get x squared equals negative 20. If we then square root both sides to get x by itself, you would have x equals the positive or negative answer of the square root of negative 20. Now 20 is 4 times 5, and we can take the square root of 4, so that's a 2. The square root of that negative is going to be our I, and the 5 stays as our square root. So it's 2i root 5, and it's the plus or minus answer for 2i root 5. And a couple more problems. Number 8, if I add 150 to both sides, negative 5x squared equals 150. Then we divide both sides by negative 5, and we get x squared equals negative 30. If we square root both sides to get our x by itself, we're going to have the plus or minus answer of negative 30. Now 30 is 3 times 10, which is 2 times 5, and nowhere in there can we really come up with a number that we can find the square root of, so we can just leave that as the plus or minus version of I root 30. So take that square root of negative 1 outside. Okay, number 9. 3x squared plus 48 equals 0. I'm going to subtract 48 from both sides. Again, this only is working because there's only one term with an x. If you have more than one term, you have to do some factoring. So we have 3x squared equals negative 48. And then if we divide both sides by 3, we get x squared equals negative 16. And if we square root both sides, 16 you can find the square root of. It is 4. And the negative becomes an I. Square root of negative 1 is I. Okay, last two, number 10. So if I wanted to get x squared by itself, I'm going to divide both sides by 8. X squared equals negative 2/8. Negative 2/8 actually reduces to 1/4, so negative 1/4. If I then square root both sides, I have the plus or minus answer of, there is an I, so an I. The square root of 1 is 1, and the square root of 4 is 2. So a little more proper way of writing that, plus or minus this 1/2 I. And number 11. Again, get x squared by itself, subtract 40 from both sides. X squared equals negative 40. Square root both sides, and we end up with x equals plus or minus the square root of negative 40. So 40 is 4 times 10. 10 can be broken down into 2 times 5. It's not going to help us much. So we can take the square root of 4, which is 2, put an I there because we have a negative square root, and we have a square root of 10 that's left over. So x equals plus or minus 2i root 10. So when we start redoing some of our quadratic formulas that have negative discriminants, we can use the negative discriminant and make an imaginary answer, so using I. Okay, bring all your questions to class on Friday. Don't forget to do your assignment, page 242, number 35 to 43, and 46 to 48. Again, that's page 242. Number 35 to 43, and 46 to 48. If you have questions on these last 3, bring them. We'll talk about them. I like those problems. See you guys on Friday.